Hi guys, I'm recording this video to help you out with lab number 3, which is the roller coaster lab. So let's get started. The first thing that they ask you to do in this lab is to look at the units for energy. So they want you to look at the expression for potential energy, which is mgh, and the expression for kinetic energy, which is 1/2 mv squared, and to come up with the units for energy. So they ask you to do it for potential energy first. So let's define all of these quantities. So m is the mass, g is the gravitational constant. They give this to you in the theory section if you're not familiar with it. And then h is the height. And similar over here, so we know that this is just the mass once again, and this is the velocity. So v is for velocity. Okay, so the next thing we have to do is come up with the SI units for each one of these quantities, and then from that we can derive our expression for energy, which ends up being a joule. So we know the SI unit for mass is the kilogram. In the theory section, they tell you the gravitational constant, and they tell you that it's in units of meters per second squared. It's the acceleration due to gravity. And then finally, we know that the height is also in meters. So this works out to be kilogram per meter, or meter squared over second squared. And then we can just do the same thing over on this side. So we know the mass is in kilograms, we know the velocity is in meters per second, and that needs to be squared. So they want you to recognize that these two things work out to be the same, and what you're looking at here is the unit for joules, so joule. So they ask you to do this using blocks or something like that, but they're really just kind of asking you the same idea. So they want you to figure out the units of all these things and use it to figure out the unit of the overall energy. So let's see, the next thing I want to talk about is they ask you about the relationship between mass and velocity and mass and kinetic energy. So let's look at the expression once again for kinetic energy. It's 1/2 mv squared. So I'll draw this too. So let's pretend this is our roller coaster. So here we are at the top. Then we come down to the bottom here. So up here, where the roller coaster is, this is going to be our max potential energy. We're going to define this as 0. So when it's all the way down here, this is going to be our max kinetic energy. So all of the potential energy up here, once it reaches the bottom of the track, is going to be converted to kinetic energy. So it's asking you to calculate the maximum possible velocity. So what is the max velocity? So that's what we need to figure out. If you know the energy at the top of the hill, and you know all of this energy becomes kinetic energy, you should be able to back out what the maximum velocity is given the height of a roller coaster. So to calculate the potential energy here, once again, it's mgh. I'm going to do it in general, and you can evaluate it yourself. So all of this mgh, if you were to solve for it, you would get some value, so whatever number this is. And this is also going to equal the kinetic energy. So this is the kinetic energy max. So if we want to figure out the velocity at this point, we need to set this kinetic energy max equal to 1/2 mv squared, and we're going to solve for the velocity. So let's do that. So velocity squared is going to end up being kinetic energy max times 2 over m. I'm just rearranging this equation here, and then solve for v, just take the square root. So it's 2 kinetic energy max over m. So I think there's a question where they ask you to basically come up with this expression. This is their logic for doing so. Yes, and then there's a part where they ask you if the mass affects the velocity that this reaches at the bottom. You can kind of see from this expression that there's, by equating these two things, there's a mass in each term. So there's a mass here and a mass here. So actually this mass tends to cancel out when you're thinking about the velocity. And you can also experiment with this when you play with the simulation. You can change the mass of the car on the track and you'll see that it reaches the same velocity at the bottom, so long as you're not changing the height. Okay, so I think that was one of the tricky parts that I wanted to help you guys out with. What else? There was one more part. I think I should talk a little bit about this part with the loop. So here I'll just write loop at the top. So they want you to figure out the potential energy needed to help this this car make it through a loop. So let me try to draw a roller coaster here. So it's going to start at the top of some hill. It's going to go down. I think eventually it zigzags through a few things, and then it's eventually going to go through a loop. Oops. Say pretend. So this has to be smaller. So this is lower in height. Than the initial hill. So here I'll fix it. So pretend this is the initial hill. So here we go. So basically it's asking you to figure out what is the minimum velocity needed to get through the loop. So basically what you have to do is pretend your car is here. So here's the car going through the loop. This is the maximum height in the loop. So you have to figure out how much potential energy is here, and then figure out the velocity based on that potential energy. So just like we did in the last part. So once again, the potential energy is going to equal the kinetic energy. So we're going to have mgh is equal to 1/2 mv squared. Again, these masses cancel out. So our expression for velocity is v squared equals 2gh square root. So this is our expression for g. I think the way they might have you solve it in Labster is to actually calculate numerical value for this potential energy. So they tell you a value for this height, and then they have you calculate this potential energy. So I don't know, I think it's something like 50,000 joules, just pretend. And then they have you equate it with this kinetic energy, so 1/2 mv squared. So you do need to know the mass of that. I think they told you it's like 300 kilograms. And from this you can solve for the velocity. Like I said, I guess the thing you need to realize is that it's asking you, the tricky part is it's asking you for the minimum velocity to get through the loop. It's not asking you for like the maximum kinetic energy or anything like that. It's asking you specifically about this part of the track. So of course this potential energy value is going to be less than it had initially, because some of it's going to be potential and some of it's going to be kinetic once it reaches this point. Okay, I think those are all of the tricky parts that I found as I redid this lab. If you still have want further clarifications, you should post this in the discussion. Yeah, and you can talk more detailed in there about your calculations, like what values have you been trying, what are the problems you're having. So I hope this helped you guys out to understand a little bit clearer, and I'll see you in class.